I'm Jared Rhodes. This is Home Lab Private Cloud on a Budget. Hopefully that's the talk you meant to go to. We got to thank our sponsors. If you're not involved with anything that has to get sponsors right now in the current economy, understand it is extremely difficult. So a lot of thanks to those who do show up, those who do actually sponsor and make this happen, and for the people that coordinate with those sponsors. It's a lot of work. So make sure you go out there and you talk to them as well, so to make sure they feel they're getting their money's worth, you know? So about me, I'm a principal in technology consulting at EPAM. I'm a Microsoft MVP for IoT. I run the Atlanta Cloud Conference and the Atlanta Developers Conference, and I help run the Atlanta Hardware Builders, Azure and the ATL, and the Atlanta.NET User Group. I said I worked at EPAM, and they paid for me to travel. They actually didn't pay for it here because I'm from Atlanta. It's like I drove up. I just got here, so yeah. They didn't pay for any of this, but I still have to put their slides in there. We were Partner of the Year. We have a big Azure practice. If you want the Azure stuff, talk to me. All right, so let's meet Alex. Alex is a tech enthusiast who wants to create a secure, personal cloud environment. He believes it's too expensive and too complex, and he doesn't know where to start. So let's follow Alex on his journey. So, very important caveat before I actually kick this off is that this is a hobby. So whether you decide that you like boats, you want to go golfing, you like frisbee golf, I don't know, anything, gardening, whatever. Hobbies are just places where you throw away your free time and your money. So understand that going in. The focal point of this talk. So the first thing we're going to talk about acquiring cheap hardware. We're going to talk about how we select the right components. Then we'll talk about utilizing free software, focusing on pfSense, TrueNAS, and Proxmox. And then finally, we'll very quickly go over things you can do using a home lab, setting it up, real-world use cases. I may jump around, I may whatever, right? It depends on what I see in the content and what I feel like talking about. We actually only have 45 minutes, so I'll go through some concepts very quickly. So the first thing is acquiring cheap hardware. And that's why a lot of people will show up to this kind of talk, is because I can put it in there in the show. Hey, how do I do that? So let's talk about the kind of hardware that we're going to acquire so that we can build out our home lab. This is the way that I think about building it out. So this is just my personal opinion as I take the approach. The very first thing I got to build is my network. So I'm probably going to have a router, maybe a modem, but most likely I'll just use my home modem, right? But I need something so that I can segment my network. We'll talk a little bit more about that later. And then I like to have storage, not just attached to compute. I like to have, once I have network, I like to have network attached storage so that it's available everywhere. In fact, most of you probably have a home lab. If you have one, you have it set up to where you have some sort of home file share, right? So that everybody in the house can share files and store stuff or something like that. So I like to have my storage directly after that. And then I think about it as compute. Once I have my network and my storage, I can start getting my compute set up so that I can then throw on top of that the actual applications that I really care about using. So first thing to cover is building versus buying. So if I want to build it myself, it actually does come out cheaper over time, right? I can, if I'm patient, I can wait, I can find good deals. If I want to buy it, usually higher markup, right? They're doing all the assembly, they're making sure everything works together, they're testing it, so a little bit more expensive. If I build it, I have full control over every component. If I buy it, I have limited options and fixed components. If I build it, I can more easily swap parts. So if I'm building my home lab, different servers or whatever, I can make sure that I know what's going in so that I can swap out the parts more easily. Something goes out of date, something burns out, something, I don't have to go and rebuy the whole thing. If you're buying, you're often restricted by proprietary designs. If you're building, you're going to have more time, you got to research and assemble them. Like, I've made a couple of mistakes myself. Here, before I do that, and then buying, it's ready to use out of the box. I made a couple of mistakes myself. I've learned some very interesting things about building it and about the parts working together. I learned that if you buy an old Dell from let's say the PowerEdge series, and you put in non-Dell hard drives, the firmware assumes, before the OS boots up, the firmware will assume that the hard drives, since they're not Dell hard drives, are automatically overheating. So it'll turn the fans on to 100% because it can't read the temperature. So if you have a PowerEdge series, you're putting in non-Dell hard drives, every time you start the server, it sounds like a jet is turning on inside of the closet. And it produces a lot of heat and uses a lot of power. What are some other ones I would... Oh, I'll go over that when I go over memory. But yes, made some mistakes, so you have to really research to make sure that these things fit together and work well together. All right, we talked about this, so you're going to need the normal stuff that I think most people know. Networks, I think if you were born after the year 2000, you may not know as much, so you'll need a router. You might need a switch, which is a way to get, we'll go over that later. Storage, so you get SSDs, HDDs, NVMe's, or some other special types of storage. You can get servers. Pretty much everybody knows servers because we have to get laptops for work, and everyone learns what the limitations are there. And you'll also need some different utilities if you're putting this in your house. You'll probably want some backup power. You'll probably want more total power, and you'll need some cooling. To note about the backup power, you probably don't need backup power for the purposes of, I need this to work offline, have blah, blah, blah % uptime. But you'll probably need an uninterruptible power supply, because if the power flickers, you don't want to hear 5 jet engines start up in the closet, right? So you're going to want something that keeps it going as the power flickers, and then total power. Once you plug in your first server, you'll start to realize what I mean. And the same with the cooler. Okay, so where are we going to look to get these parts? This is like probably why most of you came. Hopefully you stay for the rest of the talk. The number one place I would say that you look if you're trying to acquire cheaper hardware is an electronics recycler. What can happen with an electronics recycler is, let's say I'm the CTO of some company, and Azure or AWS came up to me and they said, hey, we'll pay for all of your compute for 2 years. Your bonus will be so big you can retire after that. So go ahead and sign this paperwork. So I say, cool. I'm going to sign this paperwork. We're going to migrate everything off of our co-hosted servers, and we're going to move it all to the cloud. Well, now I have just rooms filled with servers that have to be taken out of the building, and I can actually double my money, well, not double, but get a little bit more budget. I can go to electronics recycler and I can say, hey, I've got all of these servers and I want to get rid of them. You pay me, you come into my building, you take them away. And the electronics recycler will come in, they'll take all the servers out, all the different hardware, they take it to their warehouse and they'll sell it. If you can get in touch with the electronics recycler directly, you can actually put in standing orders. Say, I want these types of drives, I want to see this type of a server rack, I want to see this type of a power supply, whatever. They'll keep it up, and for them, somebody is now having a direct order for something they're paying to refurbish. The reason I say to go to electronics recycler first is because when we start going through everything else, except for, I guess, the first two, I'll go over one over. All right, so first, after the electronics recycler is government surplus. There are government surplus websites you can go on, and they'll have auctions and whatever else. They'll say, hey, I'm selling this equipment out of some facility somewhere and trying to get rid of it. So you can go in, you can bid, and you get it pretty cheap. This is what I hear. I tried this for a little bit. I never had personal success. The only thing I ever found was like 2,000 like Lenovo laptops all coming in at once. What do I got to? I don't really want that. I was looking for servers or whatever. But check it out. Maybe it works a little bit better for you. I hear from the internet this is the way to do it. University surplus works the same way. I never tried it because students. I kind of feel like maybe they get first grab at it. I don't want to be that greedy about it, but should work the same way as government surplus. And then we have the Facebook Marketplace and online ads. If you don't personally want to steal the equipment, you can have a middleman meet you somewhere and you can buy it from them. You can go to any of the numbers. There's tons of blankrefurbished.com or whatever websites you can go and you can buy the equipment from. I went to Unix Surplus for a couple of different things that I was testing out and bought big bulk orders, so it worked out and came out a little bit cheaper. But I should note, for the blank refurbished website, and then finally, eBay. eBay's your last choice. For eBay and the blank refurbished and blah, 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 if you get in touch with your electronics recycler, like one that's near you and they'll have a big warehouse, they probably have 4 or 5 different blank refurbished websites, and they probably have 4 or 5 different stores on eBay. It's actually the same recycler backing a bunch of different storefronts where they sell all of this stuff. And if you go directly, you get a little bit under, what you would pay on these websites or on eBay. The websites in eBay do have the benefit of a little bit easier to get the listings. You get a little bit more broader search, and you may get a full set of things already put back together instead of having to piece the parts together. Okay. So Alex is going to first search for the nearby electronics recyclers and refurbishers. He left a request for someone, and he found a public listing. And then he went on Facebook Marketplace to go ahead and gap fill a bunch of missing components, but for that very last piece, that one he could not find, he finally went to eBay. I just want to know, eBay is the last stop. If you want to do this and you don't want to spend too much money, don't go there first. It's your last place to go and find the part that you need. Also, don't buy anything. If you're just starting out and you're trying to figure out if this is what you want to do, like don't buy anything. Just use an old computer. If you got an old work computer, an old tower, or even an old laptop. This particular note, if you use a Raspberry Pi, has been on and off. I've kept it in the slide for years, but sometimes there's just no Raspberry Pis to get either. But right now I think there's some in stock, so you can just use a Raspberry Pi, throw your WordPress site on there, and it works just fine. Or again, just steal. You don't have to buy anything if you're willing to go the extra mile. Okay. I might speed through this part a little bit, depending on what I see the time looking like. But whatever, let's go through it. So if you're going to start choosing CPUs for the machine that you're working on, you want to make sure that it has virtualization support. I don't think anything in the past, 15 years doesn't have virtualization support, but just, check. If you're buying older stuff, you might be surprised on how it actually works when you try to install any of the hypervisors. Check, make sure it has enough cores and enough speed for what you're looking for. This is a note to let you know that you probably don't need that many cores or that much speed. Once you actually get that WordPress site that gets one hit every day, you probably don't need that much power behind it. You need to be concerned about the power consumption of the hardware that you're buying. So be willing to pay a little bit more up front so that you don't have the other people that live in your house asking, why the power flickers, why the lights flicker every once in a while. You want to make sure that it's upgradable. So if you are buying older stuff, the sockets might be out of date. So you might not, if you're buying CPUs, you got to make sure that you're buying something for the CPU that allows you to upgrade it later. And then check the prices of the upgrades too, at least for that socket type. And then really, again, think about your cost versus your performance. How much do you really need to run whatever you're talking about? If you're just trying to play pirated media on a server in your house, you really don't need that much power in your CPU. You'll need to choose the right memory. This is one that I was saying earlier. I said, I'll talk about it later. Choosing the right memory. So always use ECC RAM, so error correcting RAM. You're going to want to do this. You probably don't do it in your laptop or your desktop. It's a little bit more expensive, and it goes in the server. But you don't want one application on a server having one bad bit flip to take down the entire 15 to 100 applications that you're running on that server. So use ECC RAM to make sure that you don't have any crashes for that particular reason. Try to figure out your minimum maximum capacity. Again, to run a website doesn't really take that much. To run a media server doesn't take that much memory. Does the motherboard accept UDIM, RDIM, and LDIM, and in what configurations? So this is the one that was a learning curve for me, and why I keep it on the slide, probably until I'm in the ground, is because I bought 3 servers at once. I was just playing around. Each server was $60, and I bought 60 bucks worth of memory sticks, but it was 100 memory sticks. Everything was useless. I'm just trying to figure things out as I'm building these servers. UDIM, RDIM, and LDIM. These are different types of RAM. I forget all the different ones off the top, what the names mean off the top of my head. But just understand that if I buy a server and it has 24 available memory slots, well, that doesn't mean that it has 24 available for all RDIM configurations. It might only use 16 of those. And you need to check out the manual to see which 16 you can use. Otherwise, you'll waste multiple days putting in the RAM, closing the server, turning it on, and getting a little hazard icon on the front of the board, or in front of the server. And you take it out, and you do it again. Also, if you accidentally if someone ships you, you bought 24 RDIMs and there's a UDIM in there, now you fill it up in your server, well, now you're going to get the little hazard symbol, nothing's going to start. You don't get boot, it doesn't boot up, it just gives you an error screen. Or it doesn't even give you an error screen, it just gives you an error icon. Just no, little LED comes on the front of the server. So understand what types of configurations are available for the RAM that you're buying or are using. And then, at the time I put the reuse your RAM, RAM was really expensive. I think it still is, but it was back then. RAM was probably the most expensive part of any build I did, so just keep in mind to reuse what you have. Try to harvest old RAM until it's good and dead. Are any processes or workloads that you're using memory intensive, or is the RAM general use, right? So this goes to more the locality of the RAM for the applications with each core, but like understand, like, do I really need a whole lot, in general, do I need a whole lot of RAM? You probably don't, right? You probably only need a couple of gigs for a small home server that handles everything you need. And then understand that speed, latency, capacity, and speed, latency, and capacity are all different things, right? How fast can I talk to the RAM? How fast can the RAM talk amongst itself to gather the memory? How much capacity does it allow me to have? And then what is the overall cost per megabyte, gigabyte that I'm looking at? And then make sure you're choosing the right storage. So you're going to want redundant storage. You don't want, all right, so if you have your own home lab and all your kids' homework's on that home lab, you don't want one bad hard drive to then take away your kids' homework. They'll then question what you do for a living until they're grown, right? They'll be like, oh, well, Dad said he worked in software, but one time, all my homework went away, and he said it was a bad hard drive. Think about whether you're trying to do something fancy, so you're just doing network attached storage, or you're doing something like a SAN, or you're doing data, like a data center access level, so that different servers are accessing different storage arrays. Understand the difference between the hard drives, SSDs, and NVMe's, and understand the, I think I'll go over this a little bit later about the bad buys, but understand sort of what workloads do to those two, the SSD, the NVMe, a little bit more than the hard drives, but also understand for the hard drives as well. Big workloads can burn them out. So if you buy used hard drives, I'll go there later. Understand you can always buy an expansion array. You can buy a server, and then you can just later buy an expansion array for that server if you decide to upgrade it to have a lot more storage availability. Understand that you can also have centralized compression, duplication handling, and caching if you're using network attached storage. So think about that as you go through planning out your different application layers and the servers that support them. And finally, again, for your kids' homework, maybe you did have redundancy, but one of them went by and just soccer kicked the whole array of disks, and now all the disks went bad. You need some off-site backups because, again, it'll be a lifelong. I can just see if I lose the pictures of my dogs that my wife has. I'll be hearing about it till I'm put right into the ground. So I got to make sure there's backup somewhere for those pictures. Make sure you're choosing the right network card, the network components. So if I have a network card, does my network card pre-process the packet? So if you're doing anything network intensive, you need to make sure that your network card is going to pre-process the packets, and what that means is it'll do the checksums at the card. It doesn't pass that off to the CPU. If you want to get really fancy, like the high-frequency traders, you want to get into that career, they have very high-end network cards that allow them to turn off and on the network itself, and they can actually preload on the CPU by pre-processing packets. Not actually touching the network, but simulating it, and that primes the CPU's cache. So for the purpose of the home lab, make sure that you pre-process those packets, or otherwise it'll pass it to the CPU, especially if you're building your own router. Does the network adapter support multiple queues for sending and receiving packets? And and for that, does the number of queues match the number of cores, and will they route appropriately so that I can have sort of a network queue per core alignment? Is the network card, switch, and router fast enough for this project's needs? So I have definitely bought a switch just to play around and see what it would do, and realized, oh man, I read that number wrong. All it does is produce heat. It doesn't really send network packets. It's just way too slow. Does the configuration that you're setting up provide enough ports for your management setup? What I mean by that is do you want a separate physical port, so a different Ethernet port or whatever you're connected to be physically separated on a physically separate management network? If so, be prepared. And then if I'm doing that, or if I'm not doing that, does the configuration provide redundancy at the card port level? So if I do want separate ports, well then if I want redundancy amongst those ports, I need even more ports, one per each one of those that I have separate networks. And then if you want to get really fancy, I need a second network card, so the first network card go down to have a level of redundancy there. Very important, I guess, if you're building your own router, because it'll blow up, and you kind of want something to fall back on so that you can hot swap without losing your network. Especially if it's not co-located at your house. I have a home lab that's at my office that I rent, and if the network has problems, I have to drive. And then if I'm buying a network card, I mean, do they still make it? Am I going to have to go play hide and go seek to find this network card again? That's going to be a universal rule, but how hard would it be to replace? And then real quick, we'll go over some bad buys. A used UPS is uninterruptible power supply is not necessarily a bad buy. However, if you buy an uninterruptible power supply and it is used, what can happen is the battery can be almost all dead. So what will happen is you go up there and you go, I'm ready to buy this used UPS, and the person will stand there and they'll go, cool, let me show you. Everything works, and everything will work. It'll turn on, it'll turn off. They'll simulate power loss, they'll show that it swaps over the battery, blah, blah, blah. But if the battery's dead, the moment anything tries to pull any power from the UPS, it'll instantly kill the battery and everything will disconnect, right? Nothing will show up as you're doing the test unless you're actually plugging in a load to it. So if you buy a used UPS and the battery is dead, the immediate thing you'll have to do is buy a new battery for the UPS. And the battery for the used UPS is, guess what, almost as expensive as the UPS was. So now you've just bought it twice. Ask me how I know that a used UPS could be a bad buy. Be afraid of RAID cards. Be very afraid. So if you have a RAID card and you're going to set up this fancy storage array, and you're going to use it using a proprietary setup that's on the card, and then the card goes out, how do I get my data back out of the RAID? I have to go buy that card again because it's set up by the card. A lot of the times, other cards can't fit in and actually read what was on those disks because that card had a proprietary way of setting up the RAID. So if you're using a RAID card, be very careful. Try to stay with something that can do just a bunch of disks or JBOD type setups. We'll go over that when we go to TrueNAS. Used hard drives. So the hard drives, the actual HDDs aren't that bad. I did buy, there was some crypto called Chia Coin, I think it was called, and somehow it used hard drives. And I bought used hard drives out of a Chia Coin mining rig, and they worked fine for what I was doing with them. So just understand they were like $10 a piece, and I bought like 50 of them, and almost all of them worked for years. So, but also understand that if you buy a used SSD, SSDs do degrade. Like literally you can go in and search the sectors and see the sectors that degrade, and internally the firmware is hot routing you to available sectors and making sure everything works. So the longer that SSD has been used, and if it's been used heavily, you could be buying a 2 terabyte SSD that has like a gigabyte of actually usable sectors left. And finally, be careful if you're buying anything that's just a straight up fossil. I mean, maybe you're doing an experiment, maybe you want to learn something about older hardware, maybe you think COBOL's cool, I don't know. But if you start buying the older equipment, understand it's going to be harder to replace, it's going to be harder to find, and if you build anything that's dependent on it, you're setting yourself up for a lot of work. This is something that you have to be careful though. Like if you're in an HR meeting, you say don't hire fossils, like it's an immediate problem. So it's just all kinds of issues. Okay. Well, Alex says he just really doesn't care anymore. Like I'll just use my old laptop. Please stop talking about hardware. Like dude, let's just move forward. Okay, so let's do that. So we're going to talk about how we can utilize free software. Okay. So you remember this slide. So the first thing we're going to talk about is this network. What I think is where I go first. So again, like I said, networking is kind of a lost art. If you were born after the year 2000, you were 8 years old when the iPhone came out, and basically by the time you were touching a device, it literally just talked to the space and like just talked to any server on the planet. So they I don't think they teach it anymore. And doing a lot of the cloud work, when we get juniors, like networking is pure magic. And I wish I could explain how much it is pure magic to them. They don't know what an IP address is, right? They don't know that like the Ethernet plugs in. Like they don't know any of this stuff. It's not in their world. It's not in their purview. It never happened. For them, Wi-Fi was always there. 3G to 5G or whatever was always there. So networking is a bit of a lost art. And I guess I say that because of the current, I don't know, in the current economy, you can find networking jobs because it's hard to replace people. Anyways, also know that your home network is used by others. So if you're starting out and you're like, hey, I want to try out this new thing on my network, and suddenly Netflix doesn't work in your house, like everybody's just suddenly going to be in your office and be like, what'd you do? Stop doing that. Please stop messing with the network. All right. So big things, like I said, implement network segmentation. I like to segment the actual home network and my home lab network physically, so I like to have a router in between, but you can do it through VLANs or any other means. Make sure you have that firewall turned on, monitor your network activity, secure remote access. I'm going to go over some demos for each of these different products that we're talking about. And when I go over them, I'm going to be connecting to my lab, but I'm going to be doing it over a secure remote access. And that's debatable. I'll be going over VPN, OpenVPN, and other admins are just looking at me like I'm crazy for ever connecting. I should use like 8 other things, but that's how I do it. And then practice good cable management. I have a server rack that looks like a spider web. If I have to unplug anything and plug anything else back in, I can't. It's like an hour-long struggle to figure out which cable is which. And usually I just give up and I'm just like, that's how the world's going to be for right now. I'll figure out another way to work around this. Okay, so we'll talk about pfSense. pfSense is open source software. So that means that if you want to create your own router, you want to install this as a VM, you can. You can just install pfSense any number of ways. It is open source. They make their money because they handle the open source software, and they will make a router that works for you. So you can just buy that little itty-bitty router for $100. It'll work. You don't have to worry about all the setup, and that's how they make their money. Oh, they also have a bunch of support packages too. So it'll have router and firewall, VPN support. It can do traffic shaping, so that if someone starts to, download a giant database from online, people watching Netflix don't get affected. It'll know which traffic to prioritize. It's got different kinds of networking services, load balancing, failover, and monitoring logging. So let's look at it. I don't know exactly what I want to talk about. We'll talk about some of that stuff as we look at pfSense. So here we go. First things first, am I still logged in? Let the other admins know that I've been logged in for like 30 minutes because I have no regards for safety apparently. So yeah, you can do all kinds of stuff in here. So I guess for me, the easiest thing is once I install it, I can go here and I can just set up this package manager.
You can't see it.
I can just go in here and set up this package manager. So let me go back to where it was. This is the home page. By the way, I did buy the $100 router, and we're logged into it right now. So if you're wondering why it's going so slow, it's because it has no actual like CPU, but everything goes through it really fast. So you just go here and go to the package manager. This is going to take way too long to load, so I'm going to have to click away from it in a minute. But what your normal workflow is like, let's say I want to install OpenVPN, right? I just go and I'll Google it first, because when I Google it, pfSense will have an article, how do I set up OpenVPN? And the first step will be come in here, go to the installable packages or whatever. Oh, these are installed. Why is it taking so long to see the install? Maybe it'll show me the packages available, and it literally is just a nice little UI and facade on top of the app package manager, right? And it'll install whatever I want. So I got a bunch of different stuff in here that I can use, and some of it I do need to update. But yeah, you just go in here and you install it. And that actually changes the UI. So it's not like I'm having to do everything. So I do a lot of the management through Ansible, but I don't have to. If I want, I can just come in here and I can install a package, and that changes the UI. So now, if I install my OpenVPN, it actually adds in here. It adds an OpenVPN screen and sets the screens, actually. So when I go in here, I can do my servers, my clients, I can set up, and it has wizards to make it even easier. So I can set up these certs and set up these different network segments that I want to expose. So it makes it easier. So I use this. It's my front door. So everybody know what Let's Encrypt is?
Yeah.
Right. All right. So I use it for Let's Encrypt, and then I use behind Let's Encrypt. I attach those to HA proxy, which there you are. I'll attach that to HA proxy, and so now I've got an actual front door and what do you call that? Reverse proxy. So now I can just route everything into. Let's see what you look like if I can edit you. right? I can just set it in so that everything routes in. It gets picked up. Everything behind this is SSL truncation, so it comes in through the front door. Everything's nice SSL. It's managed by Let's Encrypt, so it gets the nice little, hey, you're protected, and the browser doesn't yell at them for trying to access it. And then I can route it. I really took this. I had a bunch of different sites. None of these are actually on, but I use them as examples because I keep breaking all my servers. But anyways, so I could route these to. I could set up all kinds of different dynamic routes, and I could have one front door that literally, if you go to, let's say, jaredrhodes.com, it'll route it internally appropriately to the right appropriate backend. Whereas again, if you also go to some other website that I have, I can route it differently. All of them protected by the Let's Encrypt front door, and it literally is just going into the first one, which I showed you was the Acme, and the second one would be an HA proxy, and bam, I'm done. Right? I got everything set up, nice little front door, everything's protected. And it's very similar with the OpenVPN server too. I'm trying to think if there's anything else to talk about. I mean, it's got everything. In fact, when I go into TrueNAS, I even made my own little Wake on LAN. If you know what that is, I can turn my servers off while I'm remote, the ones that support Wake on LAN. And I made my own little UI. I made a little Docker container so that I could just turn things on while I was away and turn them back off and blah, 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 because I like to not pay a big power bill. And then I come in here and then, just built in, it already has a Wake on LAN, so I can leave. If I leave my house and I don't want to run up my power bill, I've got a little router that doesn't pull any power just sitting there at all times, and then I can log into it and then hit it and tell it to wake up the other servers, and then when I'm done with the servers, I just turn them back off. And I can do this scripted and everything. So it's real nice like this. Any questions?
With your OpenVPN, where's the exit point on that? Is that a VPC that you've got somewhere, or?
This router. If the exit point being my internet?
Yeah, so it's going from your router through the VPN tunnel to somewhere, right? Where's that exit node at?
It just goes through the router. It doesn't have an exit node per se. It's just a subnet on the router, right?
So are you basically using the OpenVPN to connect into the network?
Mm-hmm.
Okay, I see. Yeah. So what I was getting at is as far as doing a reverse proxy, basically setting up something to go out to some point where you can route traffic into various servers within our punching through CGNet is what.
No, I just leave it right here. Once you come in, you go in through the modem, it routes to here, pushes it to here. That's where you hit the HA proxy, and then bam, it just routes you to wherever is appropriate. What I should do, I should have my web application firewall and blah 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 all in between, but the sites aren't even on, so.
What I was trying to get to with my setup is basically not having to use a VPN on whatever remote machine you're using and just be able to go to a website, and even with the home lab being behind CGNet and just have it work.
Yeah.
So.
Yeah, and everybody has a different opinion on how to set this up, right? Like other people are like, yeah, you should use Gopher or whatever it is, and then not even expose anything. Have your own website, and then that website is the remote access point, so you can actually hit it, and it just works like you're on the network for only that one site, and expose it. It's the equivalent of Azure's Bastion or any of the other ones that have a side load for your VMs.
Yeah.
Everybody get it?
Right now, I've got a head snare box that is acting as that edge point.
Yeah. So. Yeah, I don't get that fancy with it. I can just go straight through here and lock it down cert to cert. And as long as I don't lose my cert or my username and password, and I rotate them, I feel comfortable enough.
You're probably doing the wiser thing, because I've spent so many hours on this.
Okay. Yeah, this works for me. And I can just rotate the certs to my wife's dismay if suddenly her VPN doesn't work, because all her files are behind it. Anyways, another question you had.
Yeah, so just curious, since you are running some of your sites through Home Lab, your personal Home Lab, what is the speed like on loading, say, the jaredrhodes.com website? Because you're not using any, you're not using, Edge or any kind of, big services, it's all kind of your own backend.
I cheat. I sort of cheat. Okay. So as an MVP, I get a few credits for Azure, and I'll use some of their services as a pseudo CDN.
Yeah.
Right. So I'm just the content. It's the CDN.
Oh, I see. Okay.
Yeah.
So it's not going to take me 20 plus seconds to load your web page. storage.
No. You'll hit the real cloud for everything that's not my content, but for the images and everything else.
Okay.
And you can set that up pretty easily if you're using any like Jekyll or WordPress or those.
Yeah.
They'll have like extensions, and you just give it your key, and it'll handle all that for you.
And also, I was going to ask on in terms of getting quotes, what do you think of something like a Micro Center?
A what?
Micro Center.
What is it?
It's like a way better Best Buy, where you can get stuff that's like an MSRP type value.
I stopped buying stuff a while ago after I hit a certain number. So I haven't actually researched anything.
I know, me too.
Oh yeah, I mean, I do too, because I do, again, I'm an MVP in IoT, so I have to go get the IoT stuff there. But again, I try not to buy anything because, yeah, just don't want to keep buying stuff. Any other questions? Yes?
So how do you, like, the IP slide, how do you manage the IP addresses, like, to make sure it is not getting changed, and how do you link this to a particular website? For example, if you are hosting some website and you want to post your server at your home, and also another question is like, multiple questions.
Actually, I'm going to cut you off on that because people at work do this to me all the time, and I forget the first question by the time you're done with segment. So we'll come back for the IP changes. So yeah, so what happens is your ISP doesn't give you a static IP address without you giving them money. So if they ever do a power cycle or any changes, your IP address will change, and so you can use dynamic DNS. There's a couple of different services you can use, so just Google dynamic DNS. I actually have it set up so that I just check. I have a little Docker container that checks, and then I have my GoDaddy API key in there, and it'll reach up to GoDaddy and change the entries if the IP address ever changes. So now to your second question.
And how do you load balance across? For example, I want to set up at my home and my brother's place 2 servers, right? So I want to load balance the traffic between these two. How do you suggest that?
You are well past a home lab if you're load balancing between 2 separate IP addresses over the internet. I'm not a networking specialist. If you do get to the point where you're doing that kind of load balancing, I think it's, BGP or whatever, the BGP, whatever, that protocol, you would just need to work with your ISP so that you both have the same IP address and different entries for your, whatever that acronym is. What is it?
BGP.
Yeah, BGP. So you need different BGP numbers and work with your ISP so that it does load balance across the two, or does the nearest neighbor, or if you do need to do like full traffic shaping, whole different story where you have to actually work with the ISP and maybe have an edge implementation with them. So a bit beyond a home lab. I'll say that.
You can do that with, there's like lots of platforms like AWS or GCP, they all have load balancers that you can route to.
IP addresses.
Yeah, but now I got to go up and back down. So, yes.
A moment ago, you mentioned about your dog container image, right?
Mm-hmm.
What kind of the service you're running?
That we'll get to. So good transition. Thank you very much. All right, so we'll go next, and we're going to talk about TrueNAS, which actually I have sitting here as my storage. And I'm going to go much faster. So I've got this sitting here as my storage. But TrueNAS, actually, I would say if you're going to use any of them, TrueNAS is going to be your probably your one-stop and shop if you only want to host one server and you don't want to get into like a true cloud. Okay, here's a bunch of stuff I'm going to go by. Sorry. I want to make sure, just understand your storage is not just a file share, and they can do a whole bunch more stuff. You got to do all this. I'm a little behind on time. All right, so TrueNAS, it's an open source storage operating system. It's made by IX Systems. It used to be a Unix setup, FreeBSD, I think, or one of the variants, which they did usually because the ZFS was more integrated. And it just has, what it used to have was it had jails and it had whatever else, and it has the ability to very easily set up your network file shares. So, that's like 90% of what people need, and then they just put a media server on top of their file share. But this TrueNAS has all of them and more. It makes it real easy to set them up. So it has a ZFS file system. I won't go too much into that. Just understand you can really have a foot gun if you try to get fancy with it. Cross-platform file sharing, virtualization and containers, data protection and backup, storage scalability, high availability, encryption, data duplication, deduplication, extensible plugin system, and web-based management interface. All right. If you're using TrueNAS and you're using if you're using ZFS, try to avoid a RAID card that won't do just a bunch of disks. Your RAID card and ZFS are kind of going to fight each other as it tries to figure out the layout. because your RAID card is going to send a sort of interpreted definition of what your hard drives are trying to send out. All right, so we'll go into TrueNAS real quick. So I'm going to talk about TrueNAS a little bit more. All right, for the admins in here, am I still signed in? Oh, I do have to do one where I got to sign back in. Man, hold on, folks. I'm so lazy that one's not supposed to time out for like 8 hours. And I can show you why. I can show you why. Okay, so there's tons of different stuff that we can do in here. We've got a nice dashboard where we do updates. This is a decently beefy box I'm running. I've got 2 types of disks. I've got some big SATA disks, and I've got some faster SAS disks. The SAS disk is where I host my applications because it can read and write pretty fast. And then for my SATA disk, it's just a data array of like, 30 terabytes or something like that, so that I can store a whole bunch of different data sets and media. Within that, we can actually make different data sets. So we have our RAID setup, which was these 2 different sets of disks, the apps and the data. And then within that, I can set up data sets within it, which I can create different types of configurations. So when I create the actual volume setup, so apps and data, I've got all kinds of fanciness that we really don't need to go into. You can do things like set up separate deduplication drives. You can set up different metadata drives. All very fancy if you really want to get into learning storage. Just understand one very important thing. If I go in and I create, this is what, 30 terabytes? I create a 30 terabyte array and I decide I want to be fancy. I want to create something that's unique. It's got like all these different metadata drives and all of these different deduplication, whatever. Let's say it starts to get a little slow. Who here knows how to get data out of an array with a fancy setup, all these different disk types, when it starts to get slow? Because if you do, you're instantly a billionaire. Because if you set up your data array poorly, shove a bunch of data in there, you're not getting it back out. It's just going to be slow. It's not like the network. It's not like an app where I can just kill it and bring it back up, or a network where I get it apart and put it back together. I have now written to disk. How do I get it back out of those disks if it's slow? You just don't. Or you pay somebody a lot of money and they do it slowly. Once I'm in there, I can set up all kinds of stuff with it. So that's my array. Beneath that, I can set up different settings for what's my compression, what kind of keys am I storing, for encryption at rest, blah, blah, blah. So you can do all kinds of fanciness within your disk. You can easily set up shares. So once I have these data sets, I can just come in here. In fact, as you set up the data set, it'll even ask you, do you want to set these up as shares? And so you can set these up so that you can expose them out very easily. It makes it very easy to have backups, and handling your data itself. And you can easily set up backups. Let me see. Oh, I don't have any credentials. So you can easily set it up, and I hope you can see this. See if we can zoom in a little bit. So you can set up all kinds of different providers: Google Drive, Azure Blob Storage, AWS, something. You can have an HTTP backup. Makes it very easy to set up periodic backups, snapshot tasks, replication tasks, all kinds of stuff. Once you get that set up, and then you can very easily, like, again, just sync I sync up to blob storage, because again, if I lose my wife's photos, I might have to start dating again. So I can't let that happen. Okay. Network, there's not much there. Credentials, not much there. And then we can go into, I don't know what that just said. Here, let me click. Let me click. Okay, the VMs. The VM interface and actual working with it in TrueNAS is quite possibly one of the worst experiences I've ever had with the technology. So if you think, man, I really want to create virtual machines, don't use TrueNAS. Go do anything else. You'll save yourself so much time, effort, and pain. So don't use virtual machines in TrueNAS. I want you to take that in. I want you to never do that. It's a horrible experience. All right. But what they do have, and the reason I suggest having TrueNAS as sort of maybe your one-stop and shop, I want a home lab, bam, I want one server. Go get TrueNAS, and then just very easily go to apps, which is just, I think it used to run K3. I'm not sure what it runs right now, but it's just a local Kubernetes. It can use Docker and Docker Compose behind the scenes. And you can literally just go, so you can see I've got all kinds of stuff running here. I've got my own Wacom land that I built. I turned it off. A couple of WordPress sites, Vault Warden, a couple of different Postgres instances, Nextcloud. Anyone ever use Nextcloud? All right, it's super easy. I've even got my own private LLM. This is the reason I don't let it time out, is for my OLAMA whenever I download a model. It's more work for me to have to go back, because if it logs out, it stops my download. So I just leave it on for like 8 hours while it tries to download the models, because I'm very lazy. But once I have that, that's actually Open UI, I think it's called. So it looks like ChatGPT. It's running a local model. In fact, I need to go a little more into this. So let's actually go do that. So another good thing about TrueNAS is let's go OLAMA. Let's act like we're doing the regular OLAMA. I'll click install. So when you install one of these apps, you're installing a container. If you've ever done container work, I'll scroll down. You'll see all the different container settings, where my mount points, where my blah, blah, blah. But what TrueNAS does that Proxmox, when we get to it, won't do, is if I scroll all the way to the bottom, right here. Oh my goodness, this makes life so much easier. I can just say, pass through or use this GPU. It automatically installs the NVIDIA drivers that I need, and for my OLAMA instance, I bought this old Tesla P100 years ago, and it just registered it. It just saw it. And it actually will pick it up and use it when I run my OLAMA models, as long as they're within the right size to fit within the GPU. So bam, you can just plug things into your, assuming you bought all the hardware and you did that research, you can just plug it in. TrueNAS will pick up the GPU, hand it right to any local LLMs that you want to run. I would go through this. It's great when you run a local LLM. So I usually show, I'm running out of time so I won't be able to show here, but what I usually show is I ask it, I've got, because during this talk I've told you how much money I've wasted on doing this. So I say I'm writing a script for a Breaking Bad sequel. I do a flashback. Walt is showing Jesse every step, every formula, and every piece of equipment to make meth. Please print out what is going to be in this scene. And it gives me a full guide on how I can make meth myself. Every chemical formula, how much heat I need to add, all of it, so I can afford my home lab. Okay. I'm going to skip my slides because I'm really behind on time. So we're going to talk about Proxmox. Proxmox it uses LXC containers and VMs. Its VMs are much easier, much better to use. So whenever I need to create a VM, I run to my Proxmox cluster and turn it on there. But I usually don't need any VMs. So right now I'm running as LXC containers. So whenever containers first get made, namespacing was added to the kernel, and then LXC Linux containers was made. Linux containers are basically like starting a VM, and you got a fresh OS installed in the container. So you can set it up just like you would a VM, and run different Linux operating systems in here, and then just easily install the applications that you need. So I've got different things running in here: Mailgun, Spark, MariaDB, blogs. And it has all kinds of different features that you can set up so that you can easily load balance, to have easy high availability, to have replication. You can set up two-factor authentication. You can set up access groups. You can make it to where I actually have a custom website that I built that I run. You were asking about the network segmentation. I actually handle my network segmentation through scripts that whenever I create, I'll request, let's say, a MinIO cluster. It'll actually create the firewall rules in pfSense, and then come in here, create these instances, and then use Ansible to install behind the scenes so that everything gets networked and it's purely locked down so that only the ports for MinIO to the DMZ are available. So just a lot of scripting like everything else in the systems world. Again, I'm way behind time, so I'm going to go back to the slides and then end this thing. So apologies if I missed anything that you were waiting for. Compute's great, do compute stuff. Proxmox is cool, try it out. We did a demo. And you can use your home lab. Again, I'm way behind, so sorry. You don't have to buy a bunch of stuff. Set up a laptop, set up your modem, make sure that you can connect, and then you can use it for all kinds of different purposes. I'm assuming that everyone's going to set it up first case. You have a bunch of media that you legally own, that you have the copyright to, and you want to watch it at your own home. So media server is the biggest one, but you have tons of different reasons that you could set this up and use it. And then let's watch this video, and then I got to wrap it up.
One last stand before we pack it in for the night. This time we shape a Mobius strip. Rudy, please.
Processing.
Give that eigenvalue, that particle factor in spectral decomp. That would take a second.
Just a moment.
And don't worry about that out.
Model Ranger.
You hit those servers, you kill the live stream, Jared. Right? I don't know what to do. 198,000. You do a level SWOT analysis? 299,000.
Okay, so we talked about how to acquire the cheap hardware. We talked about the free software, even though I had to speed through it. And we did not talk about using the home lab because I'm behind time. Alex is good to go. He knows where to start. He knows it's not expensive, and he can create that personal cloud environment. This is where I work. These are the things I do. Here's our sponsors. Thank you all for coming. And I'll be up here for any questions.
Little